Thanks. I have my own support team with me. All right, let's get started. Or should I wait? Yeah, no, it's time to start. All right. Thanks and welcome to my little talk about modern application deployment. I'm Peter Andersson and I work for SUSE, as you probably have guessed. I have a SUSE shirt, I have a SUSE stickers on my computer, I have a SUSE logo on my presentation. My role is MA Application and Developer Platform Technical Strategist, and that's a very long, nice title. It's a more glorified SE, Sales Engineer. So that's my role. And just a short minute of me. Who am I? Why do I waste your time? So I like sailing. And a normal person, when they start with the boat life, they just start with a boat. I did it the opposite way. I started with a boat computer, which you can see on the left-hand corner there. And it worked like shit when it was exposed to sun, because it was a very glary, the screen. And another reason why I didn't buy the boat, you can see it on the top down right. I mean, this is my house, and that cost a lot to destroy the garden, and I haven't done it once, I have done it twice. And I actually went to court to the first guy that did the work, and I actually won, so I got quite much money today. So I'm happy now. So maybe I can afford to buy a boat. But that's not what I'm here to talk about. So I'm going to talk a little bit about modern deployment of software. And you probably have heard or seen quite many incarnations of this slide. Software is the competitive advantage. And what does it mean? Yeah, a car these days, it's more like software on wheels. If you take a Tesla, they have a couple of computers in there and the entertainment system and things like that. And the interaction with the car is very often done by some software in there. And banks, they are software houses these days. Yeah, you probably know that more or less, that they deploy software. They actually, everything that is in the basement of their buildings or in the cloud or wherever they have it, it's computers. And that takes care of counting the money and making sure that the customers are happy. And the competitive advantage to get the customer is probably that they can, or you can as a bank, be a little bit better than the competitors, have a cooler app, have a better calculation of stock values or whatever you have. Pardon? Yeah, and the result of doing that, all that, is that you get happier customers. Yeah, definitely. And then we come into other news or things like software-defined networks. So these days, when you go to Cisco and buy a router, you might buy a virtual appliance actually that you have in a rack. It's not a physical box with diodes and cables. It's more like a computer inside your virtual stack. And you, as OpenStack guys, you probably has touched this quite much. And the conclusion of this is that actually the developers, they are the rulers these days. If you can get the developers to be more efficient, you make more money. And if you can get the developers to understand the business and provide value to the organizations, then you are beneficial of that. And from the beginning, I tried to have a picture of a developer on the throne, you know, Game of Thrones, who was the winner there. I wanted to put the developer there, but my marketing department forbid me to use that because, yeah. So I put this picture instead. All right, and this is some other trends on the market as well, or how you work in your organizations. DevOps, instead of having that you throw the software over a fence on Friday evening and give it to the IT department, they have to install it and spend the whole weekend installing. The developers are helping, and you have shared responsibilities. So the developers and the IT department works together and try to make the software working. And if something goes down or something wrong, it goes back to the development team, and they do it directly. So they are in the same team. Continuous delivery, you probably heard of that a couple of times. What that does mean, instead of having a big chunk of upgrade that you do every 3rd or 6th month, you do it continuously. You divide the software in small portions and test, send out one version, let it see how the market react on that, and if they are happy, you continue with that, or if they are not happy, you roll it back and improve it and send it out again. Facebook is a typical example of that Facebook can change one day and you can test new functions out there, and if you don't like it, you probably shut down the app or something, and the next time you up it up, it looks like the old thing. Probably a lot of smart people sitting in the background measuring your behavior, and that's more or less continuous delivery. And also microservices, that you divide your software into small pieces, and they are communicating with each other and deploy or provide a big service. All these things together with a way of developing called 12-factor apps. That's the reality we are looking at today. And by doing all this functionality, you get faster, higher quality, and happier customers, as you mentioned in the front row. There are some interesting things here, like number 6, that the process itself should contain no states. The states should be stored outside the application, which can be very tricky and for old school developers to learn that. But if you do it, it's easier to scale out the application. If you have one instance of your application and want to scale it out, you just roll out more instances. But then you must follow these rules to make the application working that way. So this, I'll try to point here so you can see where I am. So depending on your use case, either you are want to manage everything, or if you want to do more abstract. So you have a lot of abbreviations as here. PaaS, Platform as a Service, CaaS, Container as a Service, IaaS, Infrastructure as a Service. So OpenStack is typically in this area, and then you can put something on top of that, container technology, to do more abstraction, and more to the right, you have Platform as a Service. What does it mean? Yeah, it means that that the platform takes care of the infrastructure. You, as a user or a developer, try to abstract away tricky things that takes time and hard to maintain. The more to the right you are, you get lower complexity for the people that runs the software, get more efficient, and can standardize it more. The drawback is that you lose control. And also all these layers put effort on the system and makes it more complex. So typically if you have a washing machine that you want to have some or software that controls the washing machine, you probably don't go to the right-hand side. You probably have specialized hardware that solve that problem and do that for you. So depending on the use case, you standardize around here or you land somewhere. So if you want to have high efficiency and push applications very quickly and often, you go more to right. If you want to have super control, you want to know every bits and bytes of it, you go more to the left. Does that make sense? Yeah. So, and if you talk about the infrastructure that SUSE has, on the bottom we have some kind of hardware. It could be either bare metal, or we could have the OpenStack, and on top of that, cloud, some kind of Kubernetes service, either on the cloud or running SUSE CaaS. And on top of that, we have SUSE Cloud Application Platform, which is a Cloud Foundry implementation. So depending on where you are on your journey to deploy software, you might stay on one level. Either you run your software directly on your hardware or on your operating system, or you climb up in the ladder. So what I want to do now is show a little bit how can you go to very much to the right in the big get platform as a service. So I'm going to do a first push to show what I'm talking about to get high abstraction level. So first, let's see where I am now. As totally lost it. Yeah, so this is not So here we have a super simple application. So I can show it for you. So this is it. Just more or less one line. Hi folks, I'm your first SUSE web app. And we have a YAML file that describes it, the manifest, so you can look at that. So this is what it contains on these lines. Or as my colleague told me, please do clear between every command so really see what it is. So you have, this is the description of this application. That's all I have. So what I do now is running command cf push. So what is happening now under the hood? So when I do the cf push, this is what happens under the hood. So now I went as much as possible to the right. So this is a platform as a service. So what it's doing is zip the whole directory, which I was looking at with the Ruby script and the YAML files and stuff like that, send it up to Cloud Foundry, into Blob Store, start the container, analyze it to see, okay, this is a Ruby script. Download a package, a build pack that builds a container called Droplet in this Cloud Foundry world, and does a couple of other things, and start it, and remove the building environment. So all this is taking care of the platform, and also set up the route to the application. So as a developer, I don't need to take care of all of these steps. Creating routes, connecting to network, connect to databases and stuff like that. All this is taken care of by the platform. So let's see how it looks like. So it started and it created a route to it. So this is the route. So if I look at it, see, I want to buy a ventilation system to my computer. So this is my application, actually, which was pushed. Phew. Yeah, and to prove that I'm not lying to you, we can change it a little bit. So what I can do, and it, so hi folks, first, that's like I'm at OpenInfra Day. So this is version 2. And we run a cf push, and things start happening here. So now you can see that it uploads, it compressed it creates a zip file and compress it and sends it up. So while it's doing that, I can also talk a little bit. Oh, let's see how it does it. So if you look at this, it should be actually the same route, I think. Yeah, it is. Yeah! So no fake here. So I really pushed an application and showed it. So let's go back here. So so this is me as a developer, and as a user, I just connect to it. And what I want to talk a little bit about is why do we do this? Actually, I realize. Let's show it that one. Yeah. So let's do it this way. So what is the reason why we do this? Yeah. So as a developer, you just need to run a cf push. And if you are developing or pushing applications the normal way, where all these steps is needed to do. For example, if you're using a Kubernetes or a Docker environment, you probably download a base image, you patch the image, you add extra stuff to it like glibc and others, probably connect to databases, do network connections, everything. And all this is handled, of course, by CI/CD environment, but it needs to be maintained by the developers in many cases, or in combination with the IT department or the ops team. But you do it together. But by abstracting away all these things and just using CF push, as a developer, I don't need to take care of that, just do CF push. That's the basic idea. And so we have a graphical interface to it. This is something that SUSE has done. It's an graphical interface to Cloud Foundry and also the Kubernetes and other endpoints. So we can see the applications here. So we have the web app here with the information about it. So you can see how many instances. So if you have deployed or created an application in 12-factor app, it's very simple. You just push up here, and then it's you have 2 instances of it if you have extra burden of it. Or you can create the rules that does it automatically for you. So I can show another cool app. At least I think it is cool. The resilience one. So if we do a CF push on this one, yeah, please.
So the resources, while you push the application,
yeah,
the resources required for that application, who creates it? When is it created? First time when you push it. So for example, let's say it's 1 gig of this. Can you define it in the push in some script, or how is it?
there are several things. I was very quick here as I have very little time. Let's see if I can go back to what is happening under the hood. This here. Try to answer your question. So the question was, when you push an app, who creates the resources? Is that the question? Yeah. So in this stage here, where you analyze what you get, so you push the code and it's pushed up to Cloud Foundry or SUSE Cap in this case. It gets analyzed, and there is a rule set there. So you create a build pack that is actually analyzing the code and figure out what do I need. So if it is a Ruby script, which I'm using here, it uses Ruby runtime environment and creates a droplet, which is a container image more or less, but in the Cloud Foundry world, and start that. So if you need something like a high amount of disks, you can set that in the manifest, saying I need 1 gig of disk, for example, to run this droplet, and then when it analyzes it here, it creates that space. Is that an answer to your question? Do you have a question?
That you can set quota. You have several different namespaces, and you can divide users between different organizations and set quota on each and every.
Yeah, so if I do it this way, you can see the applications here, and here you can see also in which part of the system I'm working. So in Cloud Foundry, you divided it in orgs and spaces. So, and you can set quota per org and space. So, and if I'm a developer and I'm using system and space test, and someone else is having another org, I cannot see what they do, for example, if you set it up that way. So it's very, so you don't notice the other guys here. All right, so now I pushed another application called Imperfect App, so we can take a look at that. Go back to applications and go to my space, and as you can see, there are quite many other applications running here, but I'm just interested in my app. So it's running, it has 2 instances. So why is that? Well, in my manifest I told it, when you spin it up, use 2 instances, so that's why. And here we have the route to it. So every time I reload it, so it's a round robin algorithm, it picks one of each. And it has a nice feature, it has crash me. So what is happening if I do that? I want to decouple this one so you can see actually what is happening. So, instances, so here you can see there are. And okay, if I crash it, and there it is. This one should detect that it is crashed. So if I crash it again, so it's restarting quite. So now all of them are crashed. So what is happening is that Cloud Foundry noticed that and restarted it automatically. Oops. So next time I restart it, it should be. So now it's up and running again. So this is taken care of by Cloud Foundry. So you don't need to have rule sets doing this. It's taken care of by Cloud Foundry. So it is a cool technology, which I just touched. There are quite many other functions and other demos I could run for using stateful apps and connected to CI/CD pipelines. But what is the main purpose? The main purpose, if you look at a typical build pipeline, this is what you do as a developer and in an infrastructure. You plan, you code, you build, you test, you release, deploy, and operate. And typically in a DevOps environment, development teams are involved in all these stages. They are not main responsible for these parts, but they are involved because, if the application crashes or you need to connect it to databases or patch it to something, the development team are involved in that. But all this stage here is called what we call York shaving. That means that it's not used, it doesn't produce any value for the organization if a developer starts to patch a database. So this is the part where you do, as a developer, have competitive advantages. You plan, sit in a meeting and describe what should we do, and then you code it and you build it, and that's what the developer should be doing, not the other stuff here. So that's the main purpose, to cut down that part to make it as short as possible for the organization. So this is described here. So all these steps that are called York shaving there, it's changed with CF push instead. And also another big advantage is that you can separate it. So the developers, they are responsible for the application, and the ops team, they are responsible for the platform. So the operations teams creates the platform that runs the apps, and that's their responsibility, to making sure that the apps actually is running inside it. It's development teams' work, because they own the application from the beginning to the end. And by having a platform like this, you can very clearly separate that. So it's clearer who is responsible for what. Some data here, some information about what happens when organizations use the true platform, or so PaaS solution, is that, this is the deployment time before and this is after. So as you can see that quite many, 20% increase of getting from less than a day for deployment So what happens is that it goes much faster every iteration for teams like this or organizations. So this is data we got from Cloud Foundry user surveys. And if you talk a little bit about SUSE and what we do in Cloud Foundry, we are a platinum member of the Cloud Foundry organization, and so our application or platform, SUSE CAP, is a certified deployment or a certified distribution, and we also run everything on top of containerization. That's rather unique, that you can run Cloud Foundry on a containerized environment. Very often you run it on a virtualized environment. So how much time? Okay, yeah. And there are quite other interesting projects. So when I pushed the application, so if you run a kubectl get pods minus n scf, probably, yeah, we're going to run out. So this is the environment that runs my Cloud Foundry solutions here. So there are quite many pods, and here you can see something called Diego cells. So the droplet is started inside the Diego cell. So what happens is actually you have a scheduler inside the scheduler, which is a drawback. So what SUSE is leading is a project where when you run CF push, it should create a native Kubernetes pod which is pushed. So that's something I can demo if you go to our booth, where I can show that for you, because I don't have time to show it as well right now. And that project is called Irini. And the whole idea is to make sure that you maximize the ROI. So the developers can focus on development, and the IT department can focus on running the infrastructure, and that's it, more or less. And then by having these two organizations work much more efficiently, you save money. And the whole, I have a haiku, which is a poem, a Japanese, I think it is Japanese poem, but what it says, here is my source code, run it for me, I don't care how. That's the whole idea behind Cloud Foundry. Yeah, that's what I want to talk about, and thank you for coming. And please visit our booth, where I can show the next version of Cloud Foundry or SUSE CAP, where it's deployed, for example, as a native pod when you do the CF push. Thank you. Yeah. If you, any questions? You have a very good question over there. Any other questions? No? Thanks.